Hello everyone. This video is going to be based on a presentation made at Indoor Air. In this work, what we investigated was the thermal comfort perception of school children. The work was led by Alice and took place at one of DTU Sustain's field labs. So let me get you into the work. To start off, a bit of background about the study. Uh, so there has been quite a lot of work done to understanding thermal comfort of people, but most of that work has been devoted to understanding about adult thermal comfort perception. And so from that, we know that the neutral temperature, the temperature where most people are likely to feel comfortable, is somewhere around 25 to 26 degrees Celsius. Similarly, there has also been work done which tries to understand at what temperature people would be best at work performance or task performance. And in that also, there's a temperature of around like 22 degrees when it's seen that adults perform well. Whereas the work that examined the work performance of children, they saw a slightly lower temperature at which the children are likely to perform at their best. So, based on this findings, there was a distinction noticed between the thermal comfort perception profile and like the temperatures which children feel comfortable at, the temperature at which most children are likely to be neutral. There's a difference that was observed from previous studies between children and adults. And again, to emphasize this, there's a lot more work, like hundreds of times more observation data we have for adults than for children. So the objective of the study was we started off this with this hypothesis: children have different thermal comfort responses than adults, and we're trying to establish if this is true or not. Some possible reasons for this could be that children have a higher basal metabolic rate, like they are kind of more active for their body size. It's not like they're generating more heat uh, overall, but compared to their body size, they do likely generate a lot more heat than an adult. And there could also be like fundamentally different thermal perception based on their experience and because they're still in a developing stage of both body and mind. The study wanted to focus on children, and at the end of it, we wanted to draw some potential explanations as well as add to kind of start of a database of children thermal comfort. Altogether, there were 20 students who participated in this. There were about 12 students from a Montessori school, 8 students from a Danish school. So overall, there were about 12 international students and 8 locals. Uh, all 20 students had to be in 6 different conditions. So you have them here: 18 degrees, 21 degrees, 24 degrees, and then 20 degrees, 23 degrees, and 26 degrees. And they were asked to wear different kind of clothing to kind of adjust to the slightly cooler day versus the warmer day. In each condition, they spend about 45 minutes, so that is enough time for them to kind of acclimatize to the room that the study was taking place in. The study took place in 3 identical field labs, or you can say rooms. So in each room, there was space for 4 children at a time and one of the experimenters. Uh, what we did was the room had sensors for temperature, relative humidity, operative temperature, CO2, etc. And then on one day there were with a group of settings like 18, 21, and 24, and on the next day the settings were 20, 23, and 26. So children came on 2 separate days, and on each day, each child would have spent 45 minutes in each of the room. And during the exposure, to gain some idea regarding their thermal comfort perception, etc., we asked them questions like if they were adults, we would have called them questionnaires, but since they're kids, we call this as quizzes. So there was quiz one, where like the big question for us was asking them about their thermal comfort perception. And since they're kids, instead of trying to rely too much on words, we kind of collaborated with a graphics artist to create these pictures which would depict what we mean by each point on this 7 point scale, starting from cold all the way to hot, with neutral, which is kind of ideal, uh, located in between. Then there was also other questionnaire in this quiz which talked about if they wanted to feel cooler or warmer, if they felt comfortable at a certain point or not, if they're feeling good, not good, alert, not alert, any symptoms like headaches, etc. And we also asked them what they were wearing on that particular day, but that was asked only once during the day. So the timeline is something like this. Children arrive, then we take them to a classroom. We kind of have an introduction session there. Part of the introduction session is to get them familiar with what they're going to do on that day, and also to get them familiar with the questionnaire, just to give them some background as to what's going on, what are we asking about, what is thermal comfort. We believe that without this kind of background, it would have been difficult for the children to understand what's happening and why are they being asked all these questions. So then you had three separate rounds of the children being in the each field lab, and then they went back to their school or home depending on their schedule at that day. So to kind of get children involved in it, we had this kind of cute rewards like a certificate for an assistant scientist, a badge, and there was food also. So basically, they really loved pizza. So following the conventional approach to analyzing thermal sensation data, we have here a linear regression model, which when passed, when you're trying to plot this, what we observe is that at the neutral temperature, that is the point at which the regression line crosses the uh, neutral thermal sensation vote line, that was about 22.3 degrees Celsius. So if you remember, for the adults, the neutral temperature was around 25 to 26 degrees. For the children, we're getting around 22.3 degrees. Extending it further, because this is kind of a 7 point ordinal scale, it made more sense to develop an ordinal regression model. And in this model, we combined both the temperature, the operative temperature, and the clothing that the children were wearing to get a model for the thermal sensation. And then we have these plots giving you an idea of what is the likelihood or the predicted probability of a child voting at a certain point on this scale across different temperatures. And here also you see that the highest likelihood for neutral temperature occurs approximately around 22 degrees Celsius, and the kind of zone where they are between these 2 points of like slightly warm, slightly cool, neutral, that kind of zone is between about 21 to 23 degrees Celsius. Traditionally, that has been regarded as the comfort zone, the zone between slightly warm and slightly cool. There was also the point where we try to examine like if there is a difference between the locals versus the expats, and we did see that there was a small temperature difference there. And like we didn't start off in this work trying to establish this difference between local and expats, but because there were about eight locals and about 12 expats, we could try to attempt this, and we saw that there was a difference of about 2 degrees almost between the expats and the locals, with the locals having a slightly warmer neutral temperature. So, coming back to where we started off with, adults seem to have about 3 degrees warmer neutral temperature or a comfort zone than the children. What this implies is that this is important when we are formulating thermal comfort standards for especially classrooms where you have the dominant population as children who seem to have different thermal comfort requirements than the adults. So for the future, what we're trying to achieve is like based on this work, based on the findings from this work, one of the goals would be to try to examine the rationale, like why is there a temperature difference in the neutral condition for the adults versus the children? What could account for it, and how would that get into building designs? And to support that move of having an appropriate thermal comfort condition in buildings for children, we would try to create a database for children similar to the databases that exist for adults. And these are global databases, and they have very little amount of data for school-age children collected in classrooms. And if you're interested, you can use the QR code to link up with us. Acknowledgements to all the students, the teachers, and the parents who helped us out and coordinating the activities. And finally, a thanks from Alicia. So that was it. And if you want to learn more about this effort of trying to create this thermal comfort database for children, do get in touch with us. Once again, you can uh, use the QR code to link up with us.